This is the last class of our course. So far, we have learned the basic theory regarding laws in electrical circuits. We got to know different elements, their operation, design and purpose, and we also got through some practical issues. In the previous class, we created systems on breadboards, which is a good method for testing. However, in order to achieve long lifetime of your device, you need to make it more durable, which can be done using soft soldering. We will discuss basic ways of assembly and disassembly of components using this method. You can distinguish three methods of assembly. The first one is assembly in the air, also known as pin-to-pin or through wires assembly. The next one is surface assembly, and the last one is through-hole assembly. Pin-to-pin assembly does not require a PCB, and it may be created quite quickly, but there is a high risk of short circuit if wires are not connected properly. Surface mounting, or SMD in short, is the most popular method. The elements are soldered on the front side of the PCB, where they are located. Thanks to this, these elements have short leads and their resistance and inductance are low, so they can operate with high frequencies. Through-hole assembly utilizes elements with long leads, which are mounted to the PCB through designed holes and soldered on the back side of the board. Today we will focus on this method. If you want to start soldering, you must first prepare a number of useful tools. Anti-static mat, soldering iron, solder, sucker, bending pliers, cutting pliers, and rosin. The soldering technique itself consists of several basic steps. If you have such an option, the first one would be setting the temperature. In practice, it ranges from 280 to 360 degrees Celsius. How high it will be depends on the size of the soldering field, whether it has a grommet on the other side, and whether the soldered part dissipates heat well. You can consider such a dependence. The more these surfaces and elements will efficiently dissipate heat, the more you increase the temperature, or the more you heat the place. When the element is in the hole, the tip should be placed with the largest possible surface in the place of the contact of the lid and the pad. Wait for about 1 to 3 seconds. Apply the adhesive in place of the pad contact, lid out and tip in such quantity that the concave meniscus will be created. After repeatedly doing this, you will gain practice and develop muscle memory. If the adhesive spreads badly, it means that you have either set the temperature too low, heated the soldering area too shortly, or the surface is polluted. You can have single-layer PCBs. In such cases, you assemble elements only from the side opposite to the mosaic of paths. Often, PCB has imprinted elements on the page you are interested in. On a multi-layer PCB, THT elements are soldered on the unprinted side. Let us begin with the soldering of certain elements, which are characterized only by the fact that they are used to extend the path on the opposite side of the plate. These are jumpers. The first step is to prepare the wire, preferably a copper or cut-out element. Next, you have to bend the element in such a place that the shorter bend would be about 5 to 10 mm. Then you put the prepared fragment in the given hole and check in what distance you have to make the second bending. Once you have the jumper in place, it would be better to grab the fragment just behind the second hole. You grab it farther because the bend will be done with a radius. Then you can translate the hole into both holes and bend so that it does not fall out. You repeat the process for each jumper and then solder it. Then solder the resistors and other eggshell elements in an analogous way. After finishing soldering, cut out portions of the leads about 0.5 mm above the meniscus. Many elements, for instance capacitors, transistors or integrated circuits, have spaced intervals so that you do not have to pre-bend leads. Usually, it is enough to transfer them through the holes and only bend to stabilize and solder. Elements with multiple pins, for instance integrated circuits, connection strips, etc., are assembled trying to keep a large distance between leads soldered one after the other. You do this because integrated circuits may be sensitive to too long-lasting high temperatures, and connectors are often made from plastic. Such constant heating of places in the same area can damage the elements. The main principle of assembly is the order from the lowest to the highest elements. This is connected to mounting difficulties that can be caused by a very high element which is mounted near other, much lower ones. You try to first assemble and solder all jumpers, then resistors and other axial elements, which are the lowest. Often there are integrated circuits or their bases, then capacitors and transistors depending on their dimensions. Disassembly is heating a place of assembly of a given element with a soldering iron, and when you notice that the entire binder has changed the state to liquid, it is necessary to apply the previously filled sucker to the place where the most thin is and release the trigger. If you fail to take the entire adhesive the first time, the operation should be repeated. When you fail the second time, you can try to apply a new binder or rosin and try to suck it again. Sometimes when the element has two leads, it is enough to hold one side with pliers or tweezers so that by hitting the pin slightly undermine the element to eject it. Then you repeat this action alternately for both leads. If you cannot desolder the element, you can cut off all the pins on the opposite side with a pair of pliers and then grab them one by one and tip them out. After completing all the steps, you should get a properly made electronic circuit or perform a successful service operation. These are just general rules of soldering. The practice will further familiarize you with the process. It often happens that you want to construct a fully functioning device that is to be mounted on a PCB. You can distinguish three types of such a solution. PCBs made in the factory are made most accurately. They have different solutions implemented, for example grommets, gold plating, solder mask and prints of elements. With use of appropriate techniques, you can make, using picking salts, circuits. However, many of the advantages of the above can be found very difficult to do at home. Universal boards are kind of PCB with holes and connections appropriately positioned. Thanks to them, you can start soldering finished systems very quickly. They do not have a specific purpose, and depending on how you will connect the pads, legs of elements, wires, jumpers or binder, you will get a specific connection system needed for your project. The device, which we will talk about in a moment, was made in this way to use the elements available in the set. The last thing we want to introduce you in this course is the power supply, which you can solder using the elements available in the set. You have many components and PCBs available here. We want this to be a creative exercise for you, so we decided to show you the diagram, discuss the principle of operation and provide an example of a picture of the device. We will leave your creative invention how to combine elements. The system is not complicated and it does not require key routing. Here is the diagram of our device. We start the analysis of the system with diodes that are connected in series and connect the in and out connectors together. Do you remember the lesson about potentials and reference potential? Usually, the negative pole of the power supply was for us mass. From this, it would appear that the potential in the outside should be about 1.4 volts. This is the voltage drop on two conducting diodes. Remember that from the point of view of phenomena in circuits, the voltage is important. It is the difference between potentials. That is why we will take the connection place out for 0 volts. In this situation, in will have a potential of minus 1.4 volts. This way, we have created a negative voltage. Why we used such a procedure? First of all, our LM324 operational amplifiers are not ideal and do not belong to the rail-to-rail series, so they do not achieve voltage on the output so close to the power potentials. In such a situation, supplying them with a slightly negative voltage will allow us reaching even below 0 volts at the output. The second thing is that the LM317 system is not able to regulate voltage lower than 1.25 volts. By lowering the potential, we can fully stabilize voltage close to 0, here about 50 mV. As we have already discussed how to create a negative voltage, we can go back to discussing the system from the beginning. At the input we have a large capacitor in parallel. It is used to filter the ripple coming from a rectifier or other power supply system. Then, we see in parallel the power supply section of the LM324 amplifiers with soldered close to leads capacitor 100 nanofarads. It is used to filter the supply voltage for amplifiers. Then we see the LM317 system with the implemented basic voltage regulator application. It is not used to determine the output voltage, but to create a reference voltage to all subsequent adjustments. Next, we see a load potentiometer with a resistor. The voltage, which is to be created by this atypical divider, is used to set the minimum load current. Current and voltage potentiometers regulate the voltage from 0 to 12 volts. They are used to properly adjust the power supply. The next section is the voltage setting section. The amplifier, pins 5, 6 and 7, has a closed feedback loop to the output. If you remember the principle of operation, you know that the operational amplifiers, when the feedback is realized, strive to equalize the potentials at their inputs. In other words, the voltage given by the voltage potentiometer must occur at the inverting input, so directly at the output of the system. Resistor R4, capacitor C3 and transistor T2 are transparent in the moment of operation as a voltage stabilizer. The integrated stabilizer, like many regulators, has such a feature that to properly stabilize the voltage, you need to draw some minimal current. For LM317 it is about 10 mA and it is related to the internal serial transistor. The amplifier, pins 1, 2 and 3, together with R5, R6, R7 and T1, implement the current source system. The voltage set by load, in accordance with the principle of operation of amplifiers with a closed feedback loop, will be set on the reversing input. Resistor R3 is switched on in order to increase the precision of control with a smaller range. Here we have two resistors connected with a total resistance of 20 ohms. Then we see resistor R9 connected between out of LM317 and out. This is our shunt used to measure current. The voltage on it will be proportional to the current flowing to the load. The amplifier, pins 12, 13 and 14, is a classic multiplier of 10 times. This is needed because the maximum voltage at R9 will be 1.2 volts. After this treatment, you get the voltage changing in proportion to the current on the pin 14 of the amplifier. The last amplifier, pins 8, 9 and 10, works as a comparator and its task is to compare the voltage set by the current potentiometer and that calculated by the subtraction amplifier. If the measured value is smaller, then the system turns off the transistor. If you exceed our target setting, the amplifier will turn on the transistor, which will cause the collector voltage to drop to a very low value. Note that the emitter is connected to minus 1.4 volts, so at the voltage of the transistor, about 0.2 volts, on the ADJ pin of the LM317 system, the voltage will be minus 1.2 volts. At this point, you can see why do we have R4. If you directly connected the output of the amplifier, pin 7, with the collector, it would turn out that it would have passed enough current so that you could damage it. For example, set the output to 6 volts and the transistor forces -1.2 volts. This allows you to secure the output of the amplifier. If you left the system in this way, it would turn out that the fast comparator switching could generate unforeseen oscillations. That is why we used the C3 capacitor. It allows to slightly smooth the voltage on the ADJ pin, slowing down the power supply. To filter out interference from the load, a C4 capacitor was used. In order to prepare the power supply for work, a number of activities should be performed. Supply the system with a voltage of not more than 18 volts. Set the reference voltage to 12 volts as precisely as possible using the reference potentiometer. Set the voltage potentiometer to minimum. Now the system is ready for work.
This is all we had to offer you in these classes. Thank you very much.
We are glad that we could share our knowledge and experience with you. It was a pleasure to be with you through the whole series. We hope that you'll use your creativity and gain knowledge to create electrical designs.